On March 9, 2025, the International Deep Radio Astronomy Consortium announced the detection of electromagnetic pulses emanating from interstellar comet 3I Atlas, while the European Orbital Observatory kept data collected 3 weeks prior under embargo. 2 institutions, 2 timelines, 1 escalating tension. The object that should have been just another frozen visitor from deep space is now emitting signals that challenge everything we know about comets. The question no one wants to ask aloud: are we observing an extremely rare natural phenomenon, or intercepting something that should never have been here? We're about to dive into data that most news outlets simply ignore. Its nucleus has an estimated diameter of 4.2 kilometers, a mass comparable to 600 stacked aircraft carriers. An object of this size, traveling at this speed, should exhibit chaotic cometary activity, sublimation jets firing in all directions as surface ice evaporates under solar radiation. But that's not what we're seeing. Their jets are governed by erratic internal pressure, irregular rotation, and heterogeneous composition. The precision we are measuring is incompatible with random outgassing processes. It is a mechanical cadence. Infrared analysis revealed a surface temperature of 210 Kelvin in a specific region of the nucleus. Thermodynamic models predicted 140 Kelvin at that distance from the Sun, a 70-degree difference. This suggests an internal heat source not explained by stellar radiation. Comets do not generate their own heat beyond the sublimation of volatiles, and even this release is sporadic, not sustained. What is heating 3I Atlas from within? Interstellar objects usually arrive from random angles, reflecting the chaotic ejection dynamics of their parent systems. 3I Atlas, however, travels on a hyperbolic trajectory aligned with the galactic plane within 0.8 degrees. To understand this precision, imagine aiming a tennis ball from Sao Paulo and hitting a specific window in Brasilia. The probability of a randomly ejected natural object adopting this alignment is less than 1 in 10,000. Statistical coincidence or calculated trajectory? The Southern Hemisphere Radio Telescope Network, based in Chile, confirmed the initial measurements using very long baseline interferometry. This method combines signals from multiple antennas separated by hundreds of kilometers, creating a virtual telescope the size of a continent. The angular resolution achieved allows distinguishing radio sources smaller than 1 kilometer at the distance of 3I Atlas. Dr. Emilio Vargas, technical coordinator for the Chilean network, stated in an internal communication, "The periodicity of the signal is 3 orders of magnitude above background noise. It is not an instrumental artifact. It is real." This is the emission line of neutral hydrogen, the most abundant element in the universe. In 1959, physicists Giuseppe Cacconi and Philip Morrison proposed this frequency as a universal channel for interstellar communication, arguing that any technological civilization would be aware of it. 3I Atlas is transmitting precisely there. Coincidence again? But the extremely narrow bandwidth we measured requires very specific conditions. We are working on models, but none fully explain it yet. The brightness varies by only 6% during each full rotation. Typical comets fluctuate by over 40% because their shapes are irregular, with craters, peaks, and jets in different hemispheres. A variation of only 6% indicates a regular geometry or an extremely homogeneous surface coating. Think of an almost perfect sphere or a cylinder, something with geometric symmetry. Cometary nuclei are not born this way. They are debris, chaotic accumulations of ice and rock. Then it gets worse. Doppler analysis of the signal detected a modulation that shouldn't exist. As 3I Atlas approaches or recedes in its orbit, the signal frequency should change due to the Doppler effect, like a train whistle changing pitch. But there is a component of the signal that remains constant, as if the source were actively compensating for movement. This requires an active stabilization mechanism. Comets don't do that. Absorption spectroscopy identified faint lines of heavy elements, including titanium and vanadium, in the comet's coma. These refractory metals should not be present in detectable quantities. Comets are made of ices, silicates, and light organic compounds. Heavy metals require extremely high formation temperatures, typical of planetary cores or supernova remnants. What is a comet doing with a metallurgical signature? The European Orbital Observatory collected data on thermal and spectral anomalies on February 16th. This data remained under internal peer review for 3 weeks. Only on March 9th did the international consortium release the radio measurements. 3 weeks of silence while the signals pulsed. Why the delay? Peer review protocols are standard, but this time window-generated tension among the teams. Some researchers argue that data of this magnitude should be shared immediately under scientific embargo, allowing for faster cross-validation. The most popular naturalistic explanation: asymmetric outgassing. When ice sublimates in a specific region of the nucleus, the resulting jet can create torque, altering the comet's rotation. In theory, this could produce periodicity. The problem? 3I Atlas shows no visible jets in high-resolution images. None. The coma is faint and uniform, no jets, no asymmetric torque. This hypothesis does not explain the mechanical cadence of the pulses. The coma is tenuous and uniform, no jets, no asymmetric torque. This hypothesis does not explain the mechanical cadence of the pulses. If the nucleus contained pockets of ferromagnetic material, interaction with the interplanetary magnetic field could generate periodic emissions, but polarized analyses of the signal do not show the characteristic signatures of magnetic emission. Furthermore, comets do not possess intrinsic magnetic fields strong enough for such an effect. But detections came from 3 different continents, from telescopes with distinct designs independently calibrated. The probability of identical systematic error across 3 networks is astronomical. The data are real. If there were a massive object between us and 3I Atlas, its gravity could amplify and modulate the light, but there are no lensing candidates in the line of sight. Deep sky surveys reveal no object with sufficient mass for this effect. Ruled out. Extraordinary hypotheses come into play, and here we need explicit skepticism. One possibility raised in internal discussions, but not yet published: 3I Atlas could be a degraded technological artifact. Not an active probe, but a technological fossil. The remnants of something built millions of years ago, traversing the galaxy in slow decay. The layer of ice and dust accumulated over eons would mask the internal structure, but residual power systems could still emit signals. This idea, however speculative, solves several anomalies at once. It would explain the regular geometry, the internal heat source, the precision of the pulses, and the hydrogen line frequency. But it also raises profound questions. If it's an artifact, who built it? When? For what purpose? And why is it here now? If the planet was shattered and its core ejected, we could be observing the last thermal breaths of this fragment. This would explain the heavy metals and internal heating, but it doesn't explain the radio pulses or the harmonic modulation. Planetary cores do not transmit at 1420 megahertz. There's also the possibility of a completely new geophysical process, something we have never witnessed before. Perhaps crustal resonance induced by a thermal gradient, where internal layers of the core vibrate at specific frequencies, generating electromagnetic emissions. Plausible in theory, but without observational precedent. We would be witnessing the first example of an entirely new cosmic phenomenon. It's that all explanations require us to rewrite some chapter of astrophysics or accept extraordinary implications. At that moment, the object will cross Jupiter's orbit, a distance of approximately 5.2 astronomical units from the Sun. After perihelion, solar gravity will hurl it back into interstellar space, accelerating it beyond escape velocity. In less than a year, it will be out of reach of our most powerful telescopes. The high-resolution observation windows are closing now. If they change frequency or pattern, especially on specific dates or orbital alignments, the implications become much harder to ignore. The window of scientific opportunity is now. We would have minutes, not days, to collect data during the pass. The trade-offs are brutal. More speed means less observation time. A slower trajectory requires immediate launch when preparations are still incomplete. The European Space Agency has outlined a conceptual mission using advanced ion propulsion and a Jupiter gravity assist. Ideal launch window, next 40 days. After that, propellant costs make the mission unfeasible. Estimated budget, 800 million euros. Resources. No single agency can commit without parliamentary approval and risk reviews. Bureaucracy against a cosmic clock. Observatories on all continents should share raw data in real time, allowing the global community to validate and build models collaboratively. But publication policies, competition for first authorship, and institutional embargoes delay this ideal. If 3I Atlas is natural, we are witnessing one of the most bizarre objects ever cataloged, a comet that breaks all the rules. If it's artificial, even a dead artifact, the implications rewrite our understanding of our place in the cosmos. We are no longer alone, just late. Someone has been here, or is here, traveling among the stars while we are still trying to efficiently leave Earth's orbit. Interstellar objects cross the solar system once every decade, on average. Interstellar objects emitting periodic signals, this is the first. Share it with someone who understands physics, astronomy, science. This is not a tabloid story. It's for those who want to follow what could be the scientific event of the decade or the century, happening now while most are watching cat videos. It's for those who want to follow what could be the scientific event of the decade, or even the century, unfolding now while most people are watching cat videos. An electromagnetic whisper crossing the void, repeating every 41.7 seconds, as if waiting for someone to finally pay attention. And now we are. The question is, what will we do with what we find? The 3I Atlas will continue its journey regardless of our theories, our fears, our budgetary debates. Sometime within the next 91 days during its perihelion passage, under the watchful eyes of terrestrial and space telescopes, it will give us more data, perhaps the definitive answer, or perhaps just deeper questions. We don't know if it's the last transmission of something that died eons ago or the first contact with something yet to come. And when the 3I Atlas disappears beyond Pluto's orbit, accelerating toward deep space at 87 kilometers per second, we will have only memories, archived data, and the eternal question, what did we lose by not acting fast enough? Again, like the heartbeat of something traversing the darkness, something that perhaps should never have been here but is, and we are listening.